Okay, our graph is here on the top. Notice that our graph is a little bit taller than the graphs that you see here. It's the same graph, it's just that it's stretched, and that's fine. And here I've calculated summary statistics for the questions that were being asked. So by visual inspection, we want to estimate the mean of each data set. This distribution is skewed to the right. This distribution is more symmetric. Okay, so the skewed to the right distribution should have a mean that is greater than the median. Remember that the median splits things in the middle. A symmetric distribution should have a mean that is darn near identical to the median. Okay, so my average should be somewhere around, I don't know, here maybe? It's just a visual inspection, it's just a guess. There's a lot of data here. We have 77 values, but that doesn't matter unless you're talking about the median. And in the histogram here, I don't really know what the values are because I'm not given actual data points for this histogram. I'm not referring back to my chart. I'm just looking at this picture. And with our mean, maybe it's right about here. And then our median should be to the left, and it could be maybe right spot on here. I have used StatCrunch to calculate the mean and the median of each data set. If you look above, here's the median, here's the mean. So I'm going to copy over those values. Okay, the mean for fiber is 2.1519, the median is 2. The mean for sugars is 7.0263, and the median is 7. Now, which of these two data sets will have a larger standard deviation and why? What they're asking is which one's more spread out? Is it going to be sugars? Is there a lot of data that's far away from here? Or is it going to be fiber that has a lot of data? It seems to me that this is pretty close to the mean. I would go with sugars. Sugar seems to be a little bit more spread out, but you have to do a visual inspection. Now we're going to go back to the IQR, which we did in Module 9, to calculate the range, the IQR, and the standard deviation. In StatCrunch, we've got those values up here. We have the range, we have the standard deviation, and we have the IQR by subtracting these two. I'll write those values down for you as well. Okay, what we've done here is we are actually using measures of spread. All three of those are measures to determine how variable something is. Now, looking at these numbers, which one is bigger? Which one has a larger standard deviation? Which one has a larger IQR? Which one has a larger range? And sugar wins in all three accounts. Standard deviation is going to be our measuring stick for variability for the majority of things, unless we're talking about skewed data. Because your standard deviation goes with a normal distribution or something that is bell-shaped and symmetric. You don't want to use your standard deviation for a skewed distribution. Now, which measures of center and variation are best for each data set? Well, that is determined by how something is shaped. If your distribution is skewed, you want to use the IQR. If your distribution is not skewed, if it's symmetric, you want to use standard deviation. That's something that's really important, something that you want to remember. If you have a skewed distribution, you want to use the median because it is resistant to outliers. If you have a symmetric distribution, you want to use the mean. Okay, well, fiber was skewed to the right, which means we're going to use the median. We could also use the IQR, center and variation. So this, the median goes with the interquartile range and the mean goes with standard deviation. And for sugars, we're going to use the mean and we're going to use the standard deviation as your measure of variability. One last thing we're going to talk about is the empirical rule. We're going to use this a lot more, but the empirical rule is a way to use a symmetric distribution to determine probabilities. Studies show that when you have a normal distribution or when you have a symmetric distribution that is bell-shaped and unimodal, 68% of the data fall within one standard deviation. 95 fall within 2, and 99.7 fall within 3. I can use that information to tell you what my average is and what the standard deviation, and you can use that to say, oh, okay, well, I could label my curve and figure out what percent would be that we would calculate. And we will do a lot of that. So you want to remember 68% is with one standard deviation. So they're saying the mean plus or minus sigma, that is standard deviation here, it's a representation. This is the mean plus or minus 2 standard deviations, and this is the mean plus or minus 3 standard deviations. So above or below. That's all I have for you today.